So this is the third part concerning the computation of the shaded area that we have to compute between the three circles. We have found that we need to compute this integral. So between 0 and 2 of the square root of x minus squared minus 16 minus x minus 4 squared dx. So that's the area that we need to compute here to make sure that we get the correct part. After we compute this one, we have to multiply it by 4 because this is just the 1/4 of the area. So we're going to split this integral into two parts. So first we're going to compute this one, and then we're going to compute this one, and we subtract this one. So we can use this technique 0 to square root of 16 minus x squared dx minus 0 to square root of 16 minus x minus 4 squared dx. So first we compute this one, and after that we're going to compute this one, and we subtract them. So let's first compute this one. So 0 to square root of 16 minus x squared dx. The best way to do this integral is a change of variable that we can do. Okay, we know that. So let's get x equal to 4 sine theta. Okay, so when x is 0, theta is 0. When x is 2, we get sine theta is 1/2. That means we have pi over 6. And after that, we have 16 minus 16 sine squared of theta. dx is 4 cosine theta, d theta. This gives us, after we plug dx here, we get 4 cosine theta, d theta. That means between the integral between 0 and pi over 6 square root of 16, 1 minus sine theta. Let's get the 4 outside. 4 cosine theta d theta. And we can take the square root outside of this one by the square root of 16 is 4. We take it out, we get 16 here. 0 pi over 6. The square root of 1 minus sine squared of theta is the absolute value of cosine theta, because this is cosine squared of theta. So we have cosine theta in absolute value. But since we are between 0 and pi over 6, the cosine in absolute value is positive. So we have 16 0 pi over 6, okay, cosine squared of theta d theta. Now we're going to use our formulas to compute that. We know that cosine 2 theta is 2 cosine squared of theta minus 1. So we want to compute the cosine square. So we add 1 to both sides and we divide by 2 to get cosine squared of theta is just 1 plus cosine 2 theta over 2. So we plug that one here, get 8, 0 pi over 6, 1 plus cosine 2 theta. I divided by the 2, okay? So I don't have the 2 here because I have 16 here. So I divide by 2 d theta. Okay? So now I keep 8 outside and I get theta plus 1/2 sine 2 theta between 0 and pi over 6. Okay, this is an easy integral to compute. It's so here we have pi over 6 plus pi sine 1/2 pi sine over 3. So basically we have 2 square root of 3 plus 4 pi over 3. This integral, after you evaluate, so that's what we get for the first integral. Okay, so this is our first integral. Now we're gonna compute our second integral. So to do that, we're going to use two change of variables. So the second integral is 0 to square of 16 minus x minus 4 squared dx. The first thing is we're going to change this x minus 4. So let z is x minus 4. So when x is 0, we have z is minus 4. When x is 2, z is minus 2. The square root of 16 minus z squared dx is just dz. So we have dz. Now we're going to do one more change of variable. We're going to let z is 4 sine theta. We have dz is 4 cosine theta d theta. Okay, and we need to be careful to the borns here, because when we do this change, theta is between minus pi over 2 and pi over 2. So every angle that's negative has to be expressed in this interval. Minus pi over 2 is 0, and everything that's positive has to be expressed between 0 and pi over 2. And you have to be careful. So here, when z is minus 4, we have the sine is minus 1. The sine is minus 1, it's minus pi over 2. And when we have z is minus 2, we have we have the sine of minus 1/2, that's minus pi over 6. Yes, and that's it. And okay, we have 16 minus z, that's 16 minus 16 sine squared of theta, and d theta is 4 cosine theta d theta. Let's compute. We get the 4 outside, and we get the 4 from the square root. We get another 4 here, and we get the square root of 1 minus sine squared of theta and cosine theta d theta. And we get 16 minus pi over 2 minus pi over 6. Okay, and cosine theta in absolute value. But since the cosine theta is between, let's switch here. Okay, minus pi over 2 minus pi over 6, the cosine is positive, so we get rid of this absolute value sign. So have minus pi over 2 minus pi over 6 cosine squared of theta d theta. We do the same thing that we did for the other integral. So we have, I forgot the 16 outside. So I have to have the 16 here. So I have 16, okay, 1 plus cosine 2 theta over 2 d theta. Once I compute, I get 8 minus pi over 2 minus pi over 6. So I get 8 minus pi over 2 minus pi over 6 for the 1 plus cosine 2 theta d theta. So when I compute that, I get 8 1/2 sine 2 theta plus theta between minus pi over 2 minus pi over 6. And once I do the computation here, okay, so I get this value. This is computation part only. I get 8 pi over 3 minus square root over 3. So now I have to, so the first, for the first integral, okay, for the first integral, so let me do it. I is 0 to square root of 16 minus x squared minus the square root of 16 minus x minus 4 squared dx. Okay, I need only to subtract because for the first one I get, let me see the page, what's the, so I get 2 square root of 3 plus 4 pi over 3, and I have to subtract the second one. The second one I get minus 8 pi over 3 plus minus 2 square root of 3. So once I compute that, I get 4 square root of 3 plus 4 pi over 3 plus 8 pi over 3 minus. So I get 4 square root of 3 minus 4 pi over 3. So when I factor by the 4, I get 4 square root of 3 minus pi over 3. So to get the complete integral, I multiply by 4. So let's call it C for complete integral. So it's going to be 4 times 4 square root of 3 minus pi over 3, which is going to give me 16 square root of 3 minus pi over 3. So this is the area, the whole shaded area for that integral. So we didn't use the traditional way of just using the sector, but we used the calculus, and we get the same area. I think I remember black, red, pen. I think black and red pen get the same area. Yes. So this is a new way using calculus to prove his result is right. So he got it right. This is the area.